Now we're doing question 15 on section 2.3, and we're going to employ the definition of a limit, which says for every epsilon greater than 0, there's a delta greater than 0, such that f of x minus the limit of the function is true whenever the difference of x and x sub naught is less than delta, the absolute value of that difference. So let's go ahead and build these inequalities. And so f of x is x plus 1, and the limit is 5, so minus 5, and that's going to be less than epsilon whenever 0 is less than the absolute value of x minus, and x sub naught is 4, it's less than delta. So now we've got x plus, or excuse me, x minus 1 minus 5 is 4, minus 4, less than epsilon. And let's keep going with this. To dispense with the absolute value bars, we write minus epsilon is less than x minus 4, which is less than epsilon. Now let's add 4 to each interval. 4 minus epsilon is less than x, which is less than 4 plus epsilon. Now let's let x equal, or epsilon equal 0.01. And so 4 minus 0.01 is 3.99 is less than x, which is less than 4.01. As a matter of fact, notice in this question we had to find an open interval about x sub naught on which the inequality holds. So there's our open interval, 3.99 to 4.01. Now let's find out what delta is. So again, we'll dispense with the absolute value bars by subtracting delta, which is less than x, minus 4, which is less than delta, and adding 4 to each interval, we get 4 minus delta is less than x, which is less than 4 plus delta. And now, equating 4 minus delta, 4 minus delta with 3.99 from right here, we get, when we add delta to both sides and subtract 3.99 from both sides, we get delta equals 0.01. And by the way, if we do the take 4 plus delta and equate it to 4.01 and solve for delta, we'll also get 0.01. So delta equals 0.01. And there's our open interval. Okay, we're doing question 19. And using the definition of a limit. In other words, we've got to find the open interval about x sub naught, which is 10, such that whenever this statement, this inequality is true, we're guaranteed this inequality is true. So now, let's dispense with these absolute value bars, and we can do that in this manner, putting another inequality in to the left, installing the opposite of epsilon, which is negative epsilon, to the left of that. And now we no longer have absolute value bars. We'll do the same thing here. Minus delta less than x minus 10, which is less than delta. Okay, because our x sub naught is 10, our limit is 3, and epsilon is 1. Now, let's replace epsilon with 1 and add 3 to each interval. So I'll have 3 minus 1 is less than the square root of 19 minus x, which is less than 3 plus 1. So that means 2 is less than the square root of 19 minus x, which is less than 4. Now we need to get at x, so we've got to get rid of this square root symbol, so we'll square each interval. So we get 4 is less than 19 minus x, which is less than, squaring 4 we get 16. Now let's subtract 19 from each interval. Well, 4 minus 19 is negative 15, which is less than negative x, which is less than, and 16 minus 19 is negative 3. Well, we need a positive x isolated, so we'll multiply through by a negative 1, and we get 15 is greater than x, which is greater than 3. But we have to reorient this in terms of the position of 3 and 15 on the number line, so we'll flip it over and we get 3 is less than x, which is less than 15, and there's our open interval about 10. 3 to 15. Okay, so we found the open interval. Now we've got to come up with a delta that makes this work. So let's replace x with, let's see, if we replace x with a, and I'll do it right here. If we replace x with a 3, we'll get 3 minus 10 is negative 7, and the absolute value in negative 7 is 7. And so I'm going to say delta is going to equal the minimum of, and we just said we got a 7 here. Now let's replace x with 15, and if we replace x with 15, we'll get the absolute value of, let's see, we'll get the absolute value of 5, which is 5, so we'll let, there's 2 candidates for delta, 5 or 7. Now, let's replace x here, or excuse me, delta with 5 and see what happens. So I've got negative 5 is less than x minus 10, which is less than 5. And so if we add 10 to each interval, we get minus 5 plus 10 is 5 is less than x, which is less than 15. 10 plus 5. And notice, these values, all of these values, are in this interval. So this corresponds to an interval of 5, open interval of 5 to 15. On the other hand, if we'd replaced x with 7, then we would have had a 7 plus 10 is 17. That would have been outside the interval. So consequently, we found a delta that guarantees that if this difference is less than 5, then we're going to find x coordinates, that x values that are within this interval. And we're done.